Good morning, everyone. My name is Monica and
Julie.
we're going to talk about Chapter 6. Okay, so before we begin, we want to talk about some of the basic definitions that are used in order for you guys to be able to understand the concepts that we're talking about. The most common percentage preparation that's used is weight per volume. And the units for weight per volume equals grams per milliliters. And that's basically the number of grams of a substance in 100 mLs of a solution. The next one is volume per volume. And the units are milliliters per milliliters. And that is the number of mLs of something in 100 milliliters of a preparation. The least and final percentage preparation is weight per weight, and that's grams of a constituent in 100 grams of a solution.
So we wanted to explain another equation that's going to be important when you're solving different problems. So whenever you're solving a problem, you always want to start out, if you're using weight and volume, you're always going to want to start out using your primary equation. So you're going to put grams per milliliters, and then that's going to equal a percentage. So if your problem is asking for the number of grams, then you can rearrange based on what you're looking for. So then, for example, you can use milliliters times your percentage, and that's going to be expressed as a decimal, and then that's going to equal your grams.
Okay, so to make things a little easier, Julie and I came up with 4 basic steps that you can use when solving the problems. Use these 4 steps with every problem that you have, and hopefully you can get the answer. The first step is to write down what you're given. Normally in every equation, they'll give you the quantity in milliliters, the percentage, or the grams. And based off of that, you can get your answer. The second step is to make a proportion. This step is very important because proportions set up the equation for you to find the answer that you're looking for. The third step is to circle what you're looking for. And I use X to point out that we're looking for X, which will be our final answer. And the last step is to convert. You'll only use the last step when your answer is, for example, in grams or mLs, and it's asking you to give the answer in decimals or percentage. So once again, the first step is to write what you're given. The second step is to make your proportion. The third step is to circle your X's, meaning what you're looking for. And the fourth step is to convert to the answer that they want. The first example that we're going to do is using weights per volume and the basic grams per ml preparation percentage. The question reads, how many grams of dextrose are required to prepare 4,000 milliliters of a 5% solution? So using our step, we're going to write down what we're given. We're given the 4,000 milliliters, and we're given the fact that it's going to be in a 5% solution. Those are our givens. The second step is to make a proportion. So that we all should remember that proportions look like this. The first given that we have is 4,000 mLs. Okay, so we can write 4,000 mLs here, knowing that it's always grams per ml when you're dealing with weight per volume. The second given that we have is the 5% solution. 5% means 5 grams in 100 mLs. So you can write 5 grams here in 100 milliliters. The third step is to circle what you're looking for. This is the only part in the proportion that we are missing. The last step is to cross multiply. You do 4,000 mLs times 5 grams divided by 100 mLs equals, if you cross out the mLs, you're left with your answer in grams. And the answer is 200. Okay, so the second example that we're going to do is also doing weight per volume. This example is a little trickier, but if you use our steps, you should still be able to solve it. Okay, the question reads, how many grams of aminobenzoic acid should be used in preparing 8 fluid ounces of a 5% solution and 70% alcohol? Okay, first we should write what we're given. We're given that we have 8 fluid ounces, and that's in a 5% solution. Okay, so before we move to the next steps, let's just put our units in the same category so that we know what we're looking for. So 8 fluid ounces, it's easier to get nervous because you don't know what to do. But if you remember that 1 fluid ounce equals 30 mLs, it'll be easier for you to put this in milliliters. So if we do 8 times 30, we'll get 240 mLs. Your book uses a different unit for ounces, but it's okay to round up in this situation. So now we know we have 240 mLs. 5% solution, remember that means 5 grams and 100 mLs. All right, so now all of our units are in the same. Next, we want to make our proportion. Okay, so we know this equals grams per 100 mLs. On this side, the only number we have is our 240 mLs. We don't have the grams because that's the answer that we're looking for. Second, we know that in our 5% solution, it's 5 grams per 100 mLs. So we're looking for the grams of aminobenzoic acid in 240 mLs. Now, with basic cross multiplication, you should get 12 grams. Now, once again, you can also do this example by using what you're given, which would be the 240 times the 0.05 to get your answers also. But we like to write it out so that everyone sees exactly what we did.
So our third example problem is going to be using volume in volume equations. So our question reads, how many milliliters of liquefied phenol should be used in compounding the following preparation? Liquefied phenol 2.5% and calamine lotion AD 240 milliliters. So this format is going to be one that you might see on the exam just because this is indicative of a real life pharmacy situation. So we want to start off using our steps that we have provided to solve equations. So first off, we want to write out what we're given. So this 2.5% is going to be 2.5 milliliters per 100 milliliters because we're working in volume per volume. So we're given our percentage as 2.5 milliliters per 100 milliliters of liquefied phenol. Then we're given calamine lotion, and this AD means add up to 240 mils. So 240 is going to be our final volume. So we have 240 milliliters. So using our equation of volume per volume, you're gonna say milliliters per milliliters equals, and we have our percentage on the right side, and since we're again volume in volume, we're gonna say milliliters per 100 milliliters, and that is gonna be our percentage. So plugging in everything here, we have our total volume, which is gonna be on our bottom, on the left side of our proportion. We have our percentage as 2.5 over 100 mLs. And now the only thing left that we're looking for is going to be these mLs up here. So circle what we're looking for. So finally we're gonna solve by cross multiplying. So we're gonna have 240 times 2.5 over 100 is going to equal X mLs, which equals 6. So our fourth example problem is again a volume in volume equation. The problem reads, peppermint spirit contains 10% volume in volume of peppermint oil. What volume of the spirit will contain 75 milliliters of peppermint oil? So once again, we're going to be using our steps that we laid out to solve the problem. So first of all, what we want to do is write down our givens. So in this particular problem, we're given our percentage in volume per volume. So 10% is going to be 10 milliliters in 100 milliliters. And in this problem, unlike the previous one, we are given the active ingredient volume. So what we're going to be looking for is, in this case, the total volume of the final solution. So we have 75 milliliters of active ingredient. So what we're looking for is the spirit, and that is going to be the diluent, and that is going to be the largest volume in this equation. So the way that we're going to set it up is we have our 75 mils of active ingredient, so that's going to go on the top. So we have 75 milliliters over milliliters equals our percentage of 10 milliliters over 100 milliliters. So what we're looking for is the volume of our diluent right here. And like I said, this is going to be the largest volume that's going to be contained in our proportion. So cross multiplying to get the answer, we have 75 mils times 100 mils over 10 is going to equal X, which equals, is it 750? mils.
Okay, the next example that we're going to be doing is weight per weight, which is equal to grams per gram. The question reads, how many grams of a drug substance are required to make 120 mLs of a 20% weight per weight solution having a specific gravity of 1.15? Let's clarify what specific gravity means before we move forward. So specific gravity equals weight of a substance over equal weight of water, with the units being grams per ml. Okay, so next, using our steps, we're gonna write down what we're given, which is the 120 mLs, the 20% weight per weight, which is also 20 grams over 100 grams, and then our specific gravity, which is 1.15. Since we're doing weight per weight, we know that this 120 mLs has to be converted to a grams percentage. The only way to do that is by using our specific gravity equation, plugging in what we have, and looking for what we need. So our specific gravity is 1.15, and that's equal to grams, which we don't have, over 120 mLs. With cross multiplication, we end up getting 138 grams of the substance in 120 mLs. Okay, now that we have our 138 grams, we're looking for how much of the active ingredient we need to make it a 20% weight per weight solution. So let's set up our proportion. Okay, so we know that we're given our 20 grams per 100, and that's what we want our percentage to be. We know that we have 138 grams of the solution, and we're looking for how much of the active ingredient we'll need to make this concentration 20% over 100. By doing cross multiplication, we end up getting an answer of 27.6 grams. Okay, this is our third and final example of using weight per weight. If 5 grams of boric acid is added to 100 mLs of water, what is the percentage strength of the solution? Unlike the previous question, we were given the percentage strength. Now we're given the grams of boric acid. So we're kind of doing the opposite. First, let's write what we're given, and that's 5 grams of boric acid and 100 mLs of water. Since we're working with grams per gram, we can go ahead and convert this to 100 grams of water. Okay, so let's do our proportions. We know that we have 5 grams of boric acid, and we know that the boric acid is being added to the 100 grams of water, so we can go ahead and give this a final concentration of 100 grams. We do not know what the percentage strength is here, but we do know that this is the 100% of the solution. We do some cross multiplying. X is equal to 4.76 percentage strength of boric acid in 100 grams per water. Okay, our third and final question for doing weight per weight is kind of difficult, but hopefully if you use the steps, we can figure the answer out. It reads, how many grams of a drug substance should be added to 240 mLs of water to make a 4% weight per weight solution? The first step is to write our givens, which are the 240 mLs of water and the 4% weight per weight. That equals 4 grams per 100 grams. The next step is to set up our proportion. So we know that we want the solution to be 4% here. And we know that we have 240 grams of water. Now, since we're adding something to the water, we don't know what the final solution is. We can only assume that the water takes up 96% of the solution. And we're looking for our X. With cross multiplication, X equals 10 grams.
So the next topic that we're going to discuss is ratio strength. So in previous problems, we talked about percentage strength, and ratio strength is different. So with percentages, you're always going to have some number over 100. So for example, 10% is 10 over 100. Ratio strength is going to be expressed in parts per parts. So that means that your bottom number is not always going to be 100 with ratio strength. For example, you can have something like 5 parts per 1,000 parts. This ratio strength can also be expressed like so. And so in terms of weight and volume, volume and volume, or weight per weight, this is going to mean 5 grams in 1,000 mLs, 5 mLs in 1,000 mLs, or 5 grams in 1,000 grams. So these two examples are going to show y'all how to convert percentage strengths to ratio strengths and vice versa. So the first, we're given a percentage and it's asking us to express this percentage as a ratio strength. So we're given 0.02%. So we're going to write that out, create our proportion. We have 0.02 over 100. Like I said before, our percentages are always going to be over 100. So now we're looking at our ratio strength. It's preferred to write your ratio strengths with a 1 in front of them. For example, saying 1 to 1,000. So we're going to start with our top number as 1, and this is going to be 1 part. So now we're looking for our bottom number, and that's going to be X parts. So if we just go ahead and cross multiply, we can see that 100 times 1 part over 0.02 is going to give us a ratio strength of 1 part to 5,000 parts. Now we're going to express a ratio strength as a percentage strength. So we're just going to be doing this process in the reverse order. So we start off with 1 to 4,000, and that's going to be 1 part to 4,000 parts. So since that's what we're given, we're going to start out with that on the left side of our proportion. Now, we know that our bottom number of our percentage is always going to be 100. So now what we're looking for is X. So again, cross multiplying, we're going to have 100 times 1 over 4,000. And our final percentage strength is going to be 0.025%.
Okay, the final and last topic we're going to discuss is parts per million and parts per billion. Before I get started, let's just talk about what parts per million means. Parts per million means exactly what it says, 1 part over a million. So example, if it says 10 parts per million, that's 10 over a million. Likewise for parts per billion. So the question reads, the concentration of a drug additive in animal feed is 12.5 parts per million. How many milligrams of drug should be used in preparing 5.2 kilograms of feed? Let's first write what we're given. And that's 12.5 parts per million, which is equal to 12.5 grams over a million grams. Next, we have 5.2 kilograms of feed. Let's go ahead and put these in the same unit, and that'll equal 5,200 grams. Let's go ahead and make our proportion. All right, so we already know that it's 12.5 parts per million here. It's one of our proportions. We also know that we have 5,200 grams as a final concentration here. So we're looking for the active ingredient at 5,200 grams. If we cross multiply, we'll have 0.065 And it's asking for milligrams. This is equivalent to 0.065 grams over 100. And so if you multiply that by 1,000, you get 65 milligrams.